Good morning. Math 111, Section 1.5, we're going to talk about today, entitled Solving Linear Equations. Alright, now this is a topic that's hammered pretty good in the high school and even junior high school curriculum. So we're just going to jump right in and work out a bunch of homework type exercises. Alright, this is what I call a linear equation in x. There's only one variable and there's no squares or square roots or absolute values or any of those strange things happening. It's a straight expression in x which we are asked to solve for. Alright, as you probably know, our goal is to isolate x on one side of the equation, isolate a number or a value on the other side of the equation, hence we can evaluate the solution for x. And whatever I do to one side, I should do to the other side. I would probably subtract 2 from each side, getting my numerical value on the right, and then subtract 2x from each side, getting my x variable, or my term containing the x variable, on the left-hand side. Alright, I'll perform the subtractions or additions and subtractions as indicated, and I end up with the statement x equals 3, and there is my solution for this equation, x equals 3. Up the ladder we go. Solve 3/4 y equals minus 7. Alright, the goal here is to solve for the variable, and the variable in this equation statement is y. I claim if I multiply both sides by the least common multiple of all denominators, the fractions should disappear. Well, there's only one denominator of interest here, really. That's 4. I'm going to multiply both sides by 4. Whatever I do to one side, I can balance by doing to the other side, and enabling me to isolate variables and numbers on respective sides. 4 times 3/4 on the left-hand side, the 4's cross-cancel, and I get 3y equals, on the right, minus 7 times 4 is minus 28. Alright, 3y equals minus 28. My goal is to solve for y, so I'll divide both sides by 3. The 3's cancel out on the left then, and I get a final answer of y equals minus 28/3. Alright, we're going to keep the convention. No decimals, please. Unless there are decimals stated in the problem statement, I'm not going to allow for decimal responses on online exams or in-class tests. So no decimals, please. And also, as we talked about in class, no mixed numbers. No mixed numbers, please. Oops. No mixed numbers. Alright, as we saw, mixed numbers can sometimes be confused with multiplication, can be confused for addition. So to bypass that unpleasantness from this level on, we will not be using mixed numbers, okay? Solve another linear equation. Well, linear means no squaring, no square roots, no absolute values, no exponents other than implied ones. Alright, here's an equation statement. Alright, there are values of x that will solve this equation. Our goal is to find them. I see things that can be simplified within each side before I go on. I see that minus 6x and plus 6x cancel out on the left-hand side. Looks better already. How about the right-hand side? 1 plus 2x minus 5. I'll get 2x minus 4. Adding 1 to minus 5, I get minus 4. And I get this resulting statement, minus 16 equals 2x minus 4. Well, here I'm going to isolate my variable expression on the on the right-hand side. If I add 4 to both sides, I'll get a 2x on the right, and a minus 16 plus 4 is minus 12 on the left. And of course, now I'm going to divide both sides by 2. Alright, the 2's cancel on the right, and I get x on the right now equals minus 12 over 2 is minus 6. So my solution for this equation is minus 6. X equals minus 6. Let's try something a little nastier here. Solve the following equation. This one's going to be in D. D is going to be the variable of interest. So D minus 3 times D minus 7 on the left. Alright, well, I've got to be able to break up these parentheses so I can add and combine like terms in order to isolate the variable on one side of the equation. Alright, so first I'm going to perform this implied multiplication. I'll get D minus 3D plus 21, applying my distributive law in this product on the left-hand side. On the right-hand side, I'll get 2 times 4D plus 2 times 10. Well, of course, that will result in an 8D plus 20. All right, now I'll crunch together some like terms. D minus 3D is, of course, minus 2D plus 21 on the left. And I've got 8D plus 20 on the right. That can't be simplified any further. So what I'm going to do is add 2t to both sides. Again, you can add or subtract from both sides of the equation and retain an equality statement. Of course, if I'm going to do that, I would probably subtract 21 from both sides, getting my variable residue on the right of 10d, and on the left-hand side, I'll get a 0. All right? And if 0 equals 10d, oops, let's see, have I made a mistake here? Oh yes, I made a little mistake. Let me correct that. Give me a minute here. Alright. Bear with me here. And I'm going to add 2d to both sides. That'll give me my variable residue on the right. And I would subtract then 20 from both sides, right, which will give me a numerical residue on the left. Alright, the minus 2d and 2d cancel out. 21 minus 20 gives me a positive 1 on the left. On the right, the 20 and the minus 20 cancel out, and I get 10d on the right. So I get the statement, the equivalent statement, then 1 equals 10d, and if I divide both sides by 10, the 10s will cancel out on the right. I've got d equals 1/10. Again, no decimals, no mixed numbers, please. d equals 1/10. All right. Solve another equation solution. That's all we're going to do here today is solve equations. Let's try something a little nastier. 6 times x minus 2 minus x equals minus 4 times 8x plus 3. Alright, we've got variables trapped within nested symbols of grouping. Well, on the right-hand side, I'm just going to have to work my way from the inside out. Let me see if I can evaluate these brackets inside before I go on. Well, x minus 2 minus x, I can just negate or distribute this negative sign over this set of parentheses. Let's see what we get. I'll get x minus 2, and minus x is plus x. And let me keep working on the the left-hand side here. I'll then combine like terms within those brackets. And on the left-hand side, then I'll get 6 times 2x minus 2. And on the right, I'll just have minus 4 times 8x plus 3. Well, clearly, I've got to apply my distributive law, perform these indicated implied multiplications, and 6 times 2x is 12x, minus 6 times 2 is 12. So I end up with 12x minus 12 on the left. On the right, minus 32x minus 4 times 8x is minus 32x, and then minus 4 times 3 gives me negative 12. Alright, so I'll get 12x minus 12 equals minus 32x minus 12. Alright, I will then Well, let's see, if I add 12 to both sides, I notice that they will cancel out on both sides, and I'll get 12x equals then minus 32x. Alright, I would probably then add 32x to both sides. In other words, we're trying to combine like terms, isolate a variable on one side and a number on the other. Let's see, on the left-hand side here, I'll get 44x then equals 0 on the right. Some students tend to panic when they see 0 in this fashion. Don't panic. Watch what happens. If I divide both sides by 44, the 44 cancels on the left, and I get x equals 0 over 44. Now, as you probably know, when a fraction has a numerator of 0, well, the quotient actually equals 0. 44 goes into 0 0 times, of course, so my final answer would be here not 0 over 44, but the simplified response, x equals 0. Right. You get a fresh screen here. Solve the following equation. Now this one's got some nasty fractions placed in it quite strategically, and unfortunately some students tend to come unglued when they've got fractional equations of this type, but these are really a breeze if you follow the right order of operations here. Well, I claim if I multiply both equations by the least common multiple of all these denominators, all these fractions are going to cancel out and essentially go away and leave whole numbers. Well, what's the LCM? The least common multiple of 3 and 4 and 12 is, of course, 12. 12 is the least value, or the smallest value, that is a multiple of all three. I claim if I multiply both sides by 12, these fractions will all disappear. Alright, so I'll indicate I'm multiplying both sides, all terms, by a positive 12. Now on the left-hand side, I know that multiplication is associative, so I can multiply 12 times a third and get 4, and then multiply that 4 by the remaining factor, 2x minus 1. Fraction is gone on the left. How about on the right? Well, it's a little more involved here. You've got to apply your distributive law here. You've got to multiply 12 by both of these fractional expressions. Now let's see. 5/4 x times positive 12. Well, a 4 will cross-cancel into 12 3 times, and 3 times 5x is 15x, is it not? Plus, similarly, 12 times 31 12ths. Well, here, multiplying these two expressions, the 12s cross-cancel, and I'll get a 31. So, playing my cards right with a little good housekeeping, I get an equivalent equation with no fractions. Well, it turns into the easier ones that we can solve like before. Applying my distributive law on the left, I get 8x minus 4 equals 15x plus 31. I would probably subtract 8x from both sides. That will give put my variable residue on the right. And if I'm going to do that, I would probably subtract 31 from both sides. And that results in a negative 35 on the left-hand side and a positive 7x on the right-hand side. Alright, our goal is to solve for x, so I need to clean things up a little bit, divide both sides by 7. The 7's cancel, and I get a final answer of x, well, let's see, minus 35 over 7. Yes, that does simplify. 7 goes into minus 35, of course, minus 5 times. So I've got a final, most completely simplified answer of x equals minus 5. Alright, let's try a couple of harder ones, again involving fractional type equations, or equations with fractions in them. These require a little bit of special care. This one's got 3 fractional expressions in it. But again, the mode of attack is quite similar. If you've got an equation with fractions in it, well, my advice is to multiply both sides by the least common multiple of all fractions contained in the equation. Well, what's the LCM of all 3 of these denominators? There's 5 and 2 and 5. Of course, the least common multiple is going to be 10. So I claim if I multiply both sides by 10, all the fractions should disappear, cancel out with denominator factors, and you'll have an equation with all integers left, whole numbers or their negatives left. On the left-hand side, let's apply my distributive law here. I've got to multiply 10 times 8/5. Well, 5 goes into 10 twice, and 2 times 8 is 16. From that first product, how about the second product? 10 times x plus 9 over 2. 2 goes into 10 5 times, and 5 times x plus 9. I'll just leave that product hanging until I do the same thing on the right-hand side. On the right-hand side, again, I've got to apply my distributive law. 10 times x plus 2 over 5. Well, 5 cross cancels into 10 twice, so I've got 2 times x plus 2 minus 10 times 4x will give me a 40x on the right, or minus 40x on the right. Alright, so again, with little care, these fractions have gone away and been replaced by other equivalent expressions. So now I'll distribute my negative sign, or multiply, this on the right-hand side, multiply this x plus 9 expression by minus 5. I'll get 16 minus 5x minus 45, clearing away those parentheses. On the right, I've got 2 times x plus 2 is 2x plus 4 minus 40x. Alright, let's crunch things together as much as we can before we start crossing over the equality sign. I'll get, let's see, 16 minus, we will, 16 minus 45 is going to be a minus 29, I believe. Combining the 16 and the negative 45, combining like terms on the left-hand side, equals 2x minus 40x is minus 38x plus 4 on the right. I've simplified as much as I can within each side, so I would probably want to add 38x to both sides. And if I'm going to do that, I would probably then add 29 to both sides. I'll get a 33x on the left equals, 29, these cancel, and 29 plus 4 is 33 on the right. Well, of course, I'm going to divide both sides by 33 to clean up my x term, and I get x equals 33 over 33, and of course that reduces to positive 1. So my solution for that equation is x equals 1. Alright, one more, we'll call it a day. Another kind of nasty equation with fractions in it. This one is exercise 62 on page 53 in section 1.5 in our text. We want to solve the following equation. 4 minus t over 2 minus 3t over 5 equals 2 plus t plus 1 over 3. Alright, I've got 4 terms in this equation, and 3 of them are fractional. Again, I claim if you multiply by the least common multiple of all denominators, the fractions will go away. What's the LCM of 5 and 3 and 2? I believe it's 30, is it not? 30 is the smallest number that's a multiple of both 2 and 5 and 3. So I've got to multiply both sides, all terms, applying my distributive law correctly, by 30. Alright, let's look at the left-hand side. 30 times 4 minus t over 2. Well, 2 cross-cancels into 30 15 times, so I'll have 15 times the remaining numerator, 4 minus t. That takes care of this product. Minus what? Well, I've got to multiply these two factors. 5 cross-cancels into 30 6 times, so I'll get a minus 6 times the remaining numerator, 3t, and I'll worry about that in a minute. Similarly, on the right-hand side, I've got 30 times 2. Well, of course, that's 60. Plus, about 30 times this expression. Well, 3 cross-cancels into 30 10 times, so I'll have 10 times the remaining numerator, t plus 1. Alright, now I've got to eliminate some parentheses, crunch some terms together. We're not quite there yet. 15 times 4 minus t is going to be 60 minus 15t, applying my distributive law. Minus 6 times 3 is, of course, 18, so I'll have 18t on the left, equals 60 plus 10t plus 10. Multiplying 10 times t plus 1, I get 10t plus 10. Alright, now let me crunch some terms together. Let's see, on the left-hand side, these two t multiples are both like terms. So 60 minus, is it 33t? Yes, it is. Equals, on the right, combining like terms, 60 plus 10 is 70, plus 10t on the right. Alright, what shall I do here? Well, I think I'm going to subtract 10t from both sides. I can certainly do to one side whatever I do to the other side and maintain equality. And if I'm going to do that, I would probably subtract 60 from both sides. Alright, so the 60 and minus 60 cancel. I end up with minus 43t on the left equals, well, the 10t and minus 10t cancel on the right, and 70 minus 60 is positive 10. So I'm left with this statement, minus 43t equals 10. I'll divide both sides by minus 43. Again, my goal here is to solve for t. So cleaning up the left-hand side, I get a positive t on the left equals 10 over minus 43 on the right. That's a fine answer. It's completely simplified. And remember, you can absorb that negative sign in either numerator or denominator, or even put it outside of that quotient process. All these answers are equivalent, and any one of the three will be a fine final answer. Alright, we'll call it a day, and this concludes section 1.5 video lecture, Solving Linear Equations.